Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be going through the solutions for the recent midterm exam, pre-mock exam number 1, that is for my students that are currently in preparation mode for exams coming up in May 2024. I'm going to be walking you through the solutions as I've always done throughout the whole entire year. Of course, I will pin a link to my tutorial, my monthly and tri-weekly exams tutorial playlist, where you can find other practice questions that will help you prepare for your exams coming up at the point of watching this video. Alright, now we're going to be going through a series of questions that dives off into the fields of the fundamentals of math. Of course, we're going to be looking at concepts such as a little bit of matrices, simultaneous equation, algebra, you know, the usual. We're going to be walking you through a little bit of trig as well. Transformation, of course, is very, very important as well. And you're just going to be seeing a loads of questions that are currently what you guys should be definitely knowledgeable about. Alright, so hopefully upon the point of finding this video, you find it quite useful for your preparation, and then of course it's going to help you to be a little bit more confident in going forward into the exam for 2024. So of course, if this is the first time here on the channel, do not forget to hit the subscribe button below. Leave your positive questions, comments, thoughts, suggestions down in the comment section below. Do not forget to hit the like button because it really does help the channel to grow. Please share this out to your other mathematics communities, your other mathematics friends, persons who are currently in preparation mode for exams. Alright, so that it can help everyone to get that passing grade that they need. And of course, do not forget to turn on your post notification bell. Alright, so here we go guys, let's dive on right in. Now, as I mentioned before guys, this is a midterm pre-mock exam. This is one of 2 mock exams that I'm giving prior to the CXC exam, which is held in May. So hopefully this will be a useful video to you. Here we're going to start off with question number 1. The usual instructions: answer all questions, show working where necessary. Useful formulas are provided at the back of the paper, which I had written on the board for the students. So here we go. Now of course we have, say here, to evaluate 3.6 plus the square root of 51.84 divided by 3.75. So this is the usual. We're going to start off by working out obviously what is on the root first. So this 3.6 comes back here, and then we're going to add the square root here of 51.84. so that's the square root of 51.84. that is 7.2, and we're going to divide that then by 3.75. so that's 7.2 divided by 3.75. so that's 3.75 here. So when we, of course, we can't forget the rule of PEMDAS. We have to divide before we add. So when we divide 7.2 by 3.75, we end up, say here, with 1.92. And then of course when we add those together, then we're going to end up here with a final result of 5.52. all right. Now, as I said, believe it or not, we have students that get these questions incorrect. Yes, it's valid only 1 mark or 2 mark, but we have a lot of students that make mistakes, such as they basically just work the math from left to right. And this is where these little questions are set up to throw you off. You have to remember the rule of PEMDAS, where you must work the math according to the order of the operations. So of course we know that PEMDAS, multiplication and division, should be done before addition and subtraction, and anything that is raised to a power or is under a root should be calculated, as well as anything that is within a bracket, regardless of whatever sign is in the bracket, should be worked first. Alright, do check out my PEMDAS tutorial video that is pinned in the comment section below if you want to get some more added knowledge and surety when it comes to working questions like this. All right, moving on then now to the fractions question here. As usual, we're going to have to convert our fractions here to an improper fraction, pardon me. So this question requires us to work it in parts. There is nothing really to do at the bottom of this equation here, this expression here. So we're just going to focus on the top here. We have 3.5, that is 3.5, yes, multiplied then by 1 2/3. This requires us to convert, so we have 2 times 3 is 6. 6 plus 1 is 7/2. Gonna multiply then that by 3 ones is 3, plus 2 gives us 5/3. Now usually when we're multiplying fractions, we're always looking for something to cancel, and if there isn't anything that can be cancelled, then we pretty much just multiply the numerators with the numerators. That's 35, and the denominator with the denominator. That is in fact 6 here. So this is the answer for the top. Now of course we're going to take the answer for the top here, 35 divided by 6, and we're going to divide that then by the result of the bottom. Now at the bottom we have a fraction that says 4 1/5, so that's 5 times 4 is 20, plus 1, that is 21/5. So this result here will come and attach itself here, so that's 21/5. And from we have that answer there, we're going to say then 35 divided by 6. That should multiply by the reciprocal of 21/5, which is 5/21. And like I've said before, once you're multiplying a fraction, you're looking for something to cancel out. Now if you look carefully here, that 7 can go into 21 3 times, and 7 can go into 35 5 times, making the answer very simple to achieve. So 5 times 5 is in fact 25. And 6 times 3 is in fact 18. All right, now if you want, you can leave your answer as a mixed fraction. So 18 into 25 goes one time. That will have a remainder of 7/25, and that there is your result. Okay, that is your result for that question. So hopefully you guys get some clarity on that. All right, let's move on then now to this next question here, the worded question. Now, Thomas invested $1,498 at simple interest, and he also invested the same amount at compound interest per annum. Now, our task here is to calculate the difference between the interest earned after 9 months on a simple interest plan, and what would be the difference between the interest earned on a 9-month simple interest plan and a 6 months compound interest plan. All right, so this requires us to write down the formula for compound and for simple interest. Now simple interest therefore then is equal to the principal multiplied by the time multiplied by the rate, and that is equal to, say here, 100. All right, and so to work this out, we know that the principal is going to be the 1498 that he said that he invested. Yes, that's 1498. We're going to multiply that by the time. The time here for simple interest is 9 months. But since interest is given on an annual basis or per annum, we know that we have to convert that 9 months to years. So 9 divided by 12, let's just go to the side here. 9 divided by 12, that's going to give us 0.75. So we know that the time here is in fact 0.75. And the rate, of course, I had made the correction for the students. In my typing of the paper, I did not remember to put the rate, but the correction was made in class, and they were told that the rate is in fact 6%. So we know that this is times 6, all divided by 100. Now for this particular question, where many students get caught is with the time. Whenever the time is given in months, you have to remember to calculate it, say here, in years. All right, so you have to divide whatever month you get by 12 and use the decimal form, probably to about 2 decimal places, give or take. All right, so now 1498 multiplied by 0.75 multiplied by 6, and if we divide that then by 100, then we get an interest here of $67.40. when you do the math on that. All right. Now, of course, we're going to go for the compound interest. Then we know that compound, say here, is the principal multiplied by 1 plus the rate divided by 100 raised to the power of t. Bear in mind that this formula is something that you must know mentally. It's not something that is provided to you by CXC. Alright, I don't think any actual exams provide you with a formula like this. It's a requirement for you, the student, to know this type of formula. Alright, so let's go ahead then and calculate, say here, the A, which is the amount occurring after the period. It is the same 1498 here. That's 1 plus the rate we said is 6% over 100. And of course, for the compound interest, it was for 6 months. So once again, 6 months divided by 12, 6 divided by 12, that's going to give us 0.5. So the time here is in fact 0.5. Now if we proceed here, you'll find out that 1498 will multiply. I'm going to work out what is in the bracket at the same time and raise it to the power of 5. So I'm going to go ahead and now in the bracket I have 1 plus 6 divided by 100. I'm first going to divide the 6 by 100. Ensure that you're doing the same thing that I'm asking you to do here, guys. So 6 divided by 100, that should give you 0.06. Then you're going to plus 1 to the result, and then you should get 1.06. Let's just write that down. So that's 1.06 in the bracket, and then we're going to raise that to the power of 0.5. All right, might have run out of a little bit of space here, guys. So then we're going to go ahead now and raise that now 1.06 to the power of 0.5. That should give us 1.029, and at the same time I'm just going to multiply that by 1498. My overall answer here is going to be $1,542.29 rounded off to 2 decimal places. All right, now this is the amount occurring after the period. The interest under this circumstance here, let me just grab a different color here. So the interest is actually going to be, the amount occurring minus the principal. So the amount occurring at this moment here is 1542.29, and we're going to minus, say here, the 1498 to calculate the interest that was earned from this particular plan. So therefore then we end up with 1542.29 minus the amount invested was 1498 from this plan, and interest of $44 was earned, $44.29. Now the question specifically asks that we should calculate the difference between the interest earned. So we earned an interest here of $67.41, and we earned an interest here of 44. So what was the difference in the interest earned for the different time periods? Well, obviously I earned more investing simple interest for a longer period than I earned on compound interest investing at a shorter period. All right, so therefore then the difference in the interest then would have been, let me just find some space here, guys. Let me just write it up here. So the interest difference would be equal to 67.41 minus 44.29. All right, do apologize, I ran out of space, guys. I do not want to have to write it down here, just in case you guys want to take a screenshot of the result. So that's 67.41 minus 44.29. So the difference in the interest was that I gained $23.12 more. So I gained $23.12 more by investing in the simple interest for 9 months, as opposed to investing for 6 months in the compound interest. All right, so that is what was required for this particular question. This question was valid probably about 4 marks. All right, nicely done. So not too tricky there. Let's continue here. It says calculate the total amount in both accounts after 2 years compound and 3 years simple interest. So Basically, my interpretation of this question is that this account, both accounts belong to Thomas. All right. It says calculate the total amount in both accounts. I'm not sure if we should add it. Maybe I should have written the question a little bit more clear. But I'm thinking that maybe we just need to calculate the amount that is in the account for the compound separately and the amount that is in the account for the simple interest. So we're going to do it separately, and then of course we're going to add it together then and see what would be the amount that he would have had if he made an investment in both. So again, we're now increasing this to years. Remember, interest is given on a per annum basis. So if you're given the result, if you're given the time in months, you have to divide it by 12. But if you're giving it in years, then you just use the number as it is then. So let us start off here with the 2 years compound interest plan. We know once again that A is equal to principal, open bracket 1 plus R over 100 raised to the T. So I know right away then that the amount occurring here is going to be 1498 open bracket 1 plus the rate once again remains the same, 6% divided by 100, but I've changed the time from 6 months and 9 months, and I've now placed it into 2 years here. So we can go on our calculator then and do some calculations here. So we have $1,498 multiplied by, we have already done 1 plus 6 divided by 100. We know that the answer was 1.06, so we don't need to do the work again, and that's going to be to the power of 2. So just go ahead right away now and say 1.06 raised to the power of 2, and immediately just multiply that by 1498. We know that the amount that is in this account after 2 years is $1,683.15. that is in that account there. All right, now for the simple interest, now the interest was the simple interest was for 3 years, so we're gonna go ahead then and go to this side here. So the simple interest then is equal to the principal times time times rate divided by 100. So the principal once again is 1498. The time is now 3 years. The rate is still 6%. I'm going to divide that by 100 then. All right, so we're going to go ahead then and say 1498 times 3 times 6 divided by 100. We get $269 for the interest. 269, correct? 269.64. And so of course, if we want to know what is in the account, then it's going to be 269.64 plus the initial principal 1498. In this account we have $1,767.64. Now I think that this is where the question ends. It's 2 separate accounts, so I'm just going to just write this as saying then that in account 1 for compound it would have had 1683.15, and in account 2 where you were getting simple interest we end up with a bit more. So now we increase the time. Obviously if you increase the time, if you have an investment into a simple interest account for a longer period, you most likely will earn a little bit more than when you invest in, say here, compound interest. All right, so that is it, guys. Now it says here that how long would it take for the investment to reach 449.50 earnings at simple interest? Again, I don't think I wrote this question as clear as I should. I really wanted, it's okay, but I think it would have been a little bit clearer if I had said that how long would it have taken for the investment to reach $449.50 earnings in interest. That's what I really meant to say. But hopefully my students are able to interpret this as it is. So right now the interest here is 449.50. We're looking for how long. So looking for the time formula. So time is equal to the simple interest multiplied by 100 divided by the principal times the rate. Here we transpose the simple interest formula and created a time formula. So the interest here is 449.50, and that's going to be multiplied by 100, and then we're going to divide in that by the principal, which initially we knew it was 1498, and we're going to times that by the rate, which we stated that is 6%. So that's 449.50, and we're going to multiply that by 100. At the top we end up with, say here, 44,950, and then of course we're going to divide that then by 1498 by 6, and then we end up with 8,988. So if we divide these two numbers now, it will give us an approximate time frame. So 44,950 divided by 8,988, and approximately then, well, wow, we end up with exactly 5.00, which is approximately 5 years. So basically what this is saying is that you would have to invest 1498 into the account for 5 years in order to earn interest of 449.50. all right, so it says 449.50 earnings, and earnings means interest. All right, so I don't think anything was really wrong with the question. It's just a matter of interpretation and understanding what the question is saying. All right, so that is pretty much it. It's exactly 5 years. Nicely done. All right, beautiful. All right, guys, I'm gonna move on to question 2. But I want to remind you, you need to you can check the link in the you can check the description of in the description of this video. You will find my contact information to how to join my live classes. If you're interested in me teaching you live, you can definitely check that out there down into the description of the video. And of course, if you need a scanned copy sent directly to you with the solutions, other than the screenshot that you're taking on the video at the moment, if you need the scanned document with the solutions, I can send it to you as a form of review. All right, so everything that is here on the video, you can get available. You can just email me in my email that is pinned in the description of the video, or you can contact me directly through WhatsApp. We can definitely have some arrangements done for you to help you as a student. All right, let's move on then to question number 2. We are to solve the equation below for x. We're going to solve the equation below where x is a real number and show for part 1 on the number line. All right, let me see if I okay, so this is actually the equation. All right, I think I actually should have written this question last, not sure. Here we have it here. Solve the equation below for x is a real number, and okay, so we should actually solve the equation below, and then whatever answer we get, we're going to show it on a number line, and so we go across here. Right, so we end up here with 2 open bracket 6 minus x minus 3x is less than or equal to 8. So we're going to go ahead then and you do our usual distribute. Once anything's outside of the bracket, guys, you have to use it to multiply what is on the inside. So when you approach this equation, get rid of the bracket first. So that's 2 times 6, and then we're going to have 2 times negative x. So let's do that. 2 times 6 is in fact 12, and 2 times negative x is negative 2x. Of course, bring down back your negative 3x here, and that's going to be less than or equal to, say here, 8. All right, now we can group like terms here. We're going to have negative 2x on the left. Aside that, we're going to have negative 3x as well. That's going to be less than or equal to 8. It's now important that we bring the 12 over to the right side, so that's negative 12. So we end up with negative 5x here is less than or equal to, say here, negative 4. All right, and so of course, if we split the product by dividing both sides by negative 5, we end up here with x being greater than or equal to negative 4 divided by, say here, negative 5. So we end up with x being greater than or equal to 0.8, positive 0.8. all right, so that's 8 take away 12 is negative 4. That's x is greater than or equal to 0.8. Now you'll notice here, and you may be wondering, why did the Keen reverse the sign? Because of course, on our usual explanation, we always state that if you're dividing an inequality by a negative coefficient, the sign must be reversed. To access that knowledge, I will pin a link in the description as well to my series of linear equations video that is posted on my channel. So if you have some problems with equations, solving equations like these, definitely check out my complete tutorial on that topic in algebra. You will find that video benefits you so much more than you can ever imagine. All right, so now we're required to put this on a number line. Usually we get a better number than this though. This is quite tricky, right? But you want to go to a number line here. I think we're gonna have to magnify our number line based on the answer that we're getting. So if you're asked to place this on a number line, first thing you want to do is identify your 0. I'm going to magnify the number line by placing my 1 here, my negative 1 here, and I'm going to place my, say here, 1 out here. Now, of course, in between 0 and 1, you're going to in fact find 0.5, right? So in between there and there, you're going to find 0.5. So right in between 0 and 1, you will find 0.5. So you can safely say that 0.8 would have been, say, 0.6, 0.7, 0.8, about there, approximately. So it's safe to say then that this is 0.8 and x is greater than that number. So then we're looking at just identifying, say here, this 0.8 here, carrying our line up and sending it in this direction here. Right, make sure that you shade it because it is greater than or equal to that value, and we send our arrow this direction, and that basically is the solution to this equation on a number line. All right, normally we get a nicer number than this that is easier to identify, but okay, it is what it is. Let's move on then to the next example. All right, now this particular topic here, this particular question here is also yet again another type of equation where we're looking at then, say here, solving a quadratic equation. And we can know that this is a quadratic equation simply by the fact that this has a square right here. And so once you see an equation with 3 terms with a constant, a term with an x and a term with an x squared, we know it's a quadratic equation. This is perhaps the most successful video on my channel in terms of the amount of views. It did went a little bit like it went out. Lots of persons seem as if they wanted to know how to solve quadratic equations. So it did went to about 600 views. That's the maximum views that I've gotten on the channel. So definitely you want to check that tutorial out. I have a bunch of detailed examples that walks you through situations like what you're about to encounter. Now, our usual quadratic equation is usually written in the form ax squared plus or minus bx plus or minus c, and that's equal to 0. Now, there's something kind of off with the setup of this equation. You're going to find here that it's not in the correct order as we are accustomed to it. So we're going to need to get this in the correct form here. We have the 4x squared all the way on the right. So let's keep it there on the right. We're going to bring over the 3x to that side here. That's minus 3x. And then we're going to bring that 2 over there towards the right as well. So that's minus 2. And of course, we know that what is going to be left here on the left here is equal to 0. There's nothing left on the left. All right. Now, as opposed to having the equal 0 to the back side of the equation here, it is okay to therefore just put the 0 also here on the right because it's the same procedure. All right, so now we end up here with our usual quadratic equation setup. Now we need to establish the values of a, b, and c. So a is always the number in front of the square, so in this case a is 4. B is the number that appears before the x, so that in this case here b is minus 3, and c here is equal to, say here, minus 2. All right, and then of course from we do that, then we're going to rewrite our formula then that x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by, say here, 2a. This formula is provided at the front of the booklet. Well, it's provided on the formula sheet that is at the front of your booklet for your exams. So most times studying the formula is good, knowing it is good, but it is given to you by CXC, so you can utilize that one opportunity where the formulas at the front are useful. All right, so we're going to go ahead then and proceed. We know that x then is going to be equal then to, say here, so x then is equal to the negative of b. B is in fact a negative number, so that's negative of negative 3. We're going to have plus or minus the square root of b squared. Well, in this case here, b again is minus 3, so that's the square root of minus 3 squared. And of course, we're going to have take away 4 multiplied by a. We stated that it's 4 times c. We stated that c is negative 2. And then all of that then will be divided by 2 multiplied by a, which in this case we know is 4. All right, so x then is equal to the double negative here gives us a positive, so that's 3, plus or minus, of course, when you square a negative number, you're going to get a positive result, so that's 9. Of course, this negative here will affect the negative out here, so negative multiplied by negative is positive. And 4 times 4 is 16. 16 times 2 is in fact 32. And that all then will be divided by, say here, 2 times 4 is in fact 8. All right. We then move on nicely then to saying that x is equal to 3 plus or minus the square root of 41. And that all will be divided then by, say here, 8. All right. Now nicely then we end up here then with x being equal to 3 plus or minus the square root of 41. When we go on our calculator, we end up with, say here, 6.40, or the 6.4 is fine. 6.4 is fine, and that's all divided by, say here, 8. Now we need 2 solutions for our equation. We're going to have one solution that states that, say here, let me see, hold on, give me a sec. So we have 2 solutions here. We're going to have, say here, x is equal to 3 plus 6.4 divided by 8. And we have also here that x is equal to 3 minus 6.4 divided by 8. All right, so the solutions for this then works out that, say here, 3, just a second here, guys. So 3 plus 6.4 all divided by 8, and that is 1.12. That's fine. 1.12 or 1.2 is fine, or 1.12. I'm just going to work with one decimal place, 1.2. And of course, 3 take away 6.4 all divided by 8. Then that works out that x also is equal to negative 0.43. Negative 0.43 rounded off. 0.4. Negative 0.4 is fine. All right. And those are our 2 solutions to this particular quadratic equation then. All right. Beautiful. So that brings us to the end of that question. That question value is probably about 3 marks, maximum 4, minimum 3. Give or take, CXC sometimes can be a little bit stingy with the marks, so don't pay too much mind to the amount of marks awarded. Just focus, guys, on getting the actual question or problem correct. All right, beautiful. Now let's wrap up the algebra section of this paper here. We end up being asked here to factorize this particular expression then. So we end up with 3x minus 6y plus ax minus 2ay. I have a tutorial coming out on factorization, so be sure to hit the subscribe button below, guys, and be notified whenever those types of videos come out. I'll be having a lot of tutorials being posted on the channel, and I have a lot of past papers compilation coming out as well, so you want to stay tuned for that. If you're watching this video, this month of April is going to be an exciting month for preparation for exam. You all have the opportunity to do extremely well on the exam if you spend some time watching some of these tutorials that I have here on the channel. All right, let's move on then. So we're gonna go ahead then and group like terms then, as we always would do here. All right, so by grouping like terms, then we end up grouping here and here together, and here together. All right, now the first two terms have a common factor of 3. 3 can go into both 3x and 6y. So open the bracket here, 3 divides into 3x, goes x times, and 3 goes into 6 2 times, leaving back the uncommon factor y. Now the common factor in these next two brackets here is in fact the letter a, because a repeats itself. A divides into ax, goes x times, and a divides into 2ay. 2 a's cancel, leaving us with negative 2y here. All right, and then you can see that both brackets repeat themselves, so it becomes a common factor. And of course, because the x minus 2y is a common factor and I grab it out, then what is left here is 3 plus a. Please bear in mind, guys, that when you get questions like these, sometimes if you don't end up with the same things in the bracket, then if that situation pops up, you may need to regroup either the first two terms, like put the 6y in front of the 3x, or you have a choice of putting negative 2ay in front of the ax if you are not getting the same things in the bracket. You must get the same expressions in the bracket for you to complete the factoring. All right, nicely done there. All right, I'm going to move on then to expand and simplifying this expression here. We have 2k minus 3, open bracket, k minus 2. I have a video on this. It's called folding technique, or in my country we say that it's the bird beak method. All right, where what we basically do then is that we use the term that is on the outside of the bracket here. All right, so what we do here is that we use the first term to multiply the first term, and the first term to multiply the second, and the second term to multiply the first, and the second term to multiply the second. So it tends to create this sort of bird beak, like a little eagle mouth to it. All right, now I find that a little bit tricky, especially if the terms are like composite. I prefer really and truly telling a student that they should actually take the first term, 2k here, and open a bracket and multiply the second bracket over here, that's k minus 2. I think this is more of a more lucid approach to the question. And then of course we're going to take the minus 3 here, that's the second term in the first bracket, to again multiply the second bracket over there. So you notice that k minus 2 repeats itself twice. All right, this is what we call the reverse distribution law. Basically this is the factored expression, and then we're trying to go backwards to get the quadratic expression that provides this answer. So then we can just go ahead simply then and just distribute the 2k here. I think it's more obvious, and then students will pay a lot more attention to signs. 2k times k is 2k squared. 2k times minus 2 is minus 4k, so that's 2k times 2, that's minus 4k. Minus 3 times k is 3k, negative by negative is positive, 3 times 2 is 6. All right, and so now most times when you get expressions like these, you're going to find that the like terms, most times, not all the time, but most times you find that the like terms appear in the middle, because we have the 2k squared here and there's no other square term to add to that. So we have minus 4 minus 3, that is minus 7k, and then we're going to have positive 6 here. All right, now during my experience of teaching students in my country, in Jamaica, a lot of students will get questions like these incorrect simply because of signs. All right, now the type of students that I teach crash course learning. So the syllabus is supposed to take like 2 years to be completed, and I have students that are trying to do the exam within 7 months. So the style of teaching is a little bit different. So if you're watching this video and you're wondering why am I explaining the problem like this, it is merely just to help the audience that I have to understand how to prepare for an exam in a short space of time. All right, so assuming then that if you guys are already familiar with these concepts, then then you know it's a very simple problem. But for the students who are watching this with the aid that it's going to help them to prepare for the exam in a short space, then this is exactly what you guys need to do. All right, we're going to move on then to the next question. It says make V the subject of the formula. Again, you can check out my change subject of the formula video. I have a part 1 and a part 2 to that video, so you definitely want to check that out, guys, when it comes to transposing an equation. Now here we have t is equal to the square root of v over 2x. Particularly, you'll find a video on part 2 where it says that, I think the title of the thumbnail is roots and powers. So if you want to be effective when it comes to this type of equation, definitely check out my roots and power transposition of the formula video. I will pin a link in the comments as well. All right, so let's just rewrite the question here. We have t is equal to the square root of v divided by 2x. Of course, the first thing that we need to do here is to get rid of the root sign. Now this is a square root, so we know we have to square both sides of the equation. So I'm going to square the t here. So I'm going to square the t here, and I'm also going to square the square root of v divided by 2x. I'm going to square that as well. So of course, what happens now when you square a square root? Well, obviously the t is going to become t squared. And then of course, what happens now is that the square root will be cancelled by the square. And we discussed elaborately why this happens in that tutorial video, so be sure to check that out at a time convenient to you. So t squared is equal to v divided by 2x. Now this question is quite a simple question than what I would have expected. Say here we are looking for v, we can just simply put the t squared over 1, and we can simply go ahead then and cross multiply. All right, so we have v multiplied by 1 is v, and then of course we end up with t squared times 2x. You can write it as 2x t squared or t squared x2, or simply just put 2t squared x, no problem. So that is our final result. Then v is equal to 2xt squared. All right, v is the subject of the formula once it has been isolated. All right, very, very simple, short and spicy. Now moving on then next to this question here. The lines whose equations are 3x plus 2y equal 2 and 4x minus 2y equals 6 intersect at x and y. Our task is to show that the point of intersection is 1, minus 1. Now, one of the things that I've recognized, and I've not been paying much attention to past paper questions of recent, over the past couple of years, I've kind of just like taught math, not really focusing on the question, but I've been reviewing the CXC past paper trend, and I find that CXC does two things. They start to kind of ask you to prove what the answers are, as opposed to asking you to calculate the answer. They'll start giving you the answers to the question and then asking you to show how the answer was derived. So they're starting to ask the question in more of a reversed form. I'm more accustomed to me, the student doing the exam, to calculate the answer. So what I find is that a question like this throws off many of my students currently that I'm teaching at the point of making this video. And when I got the review from them, they did not recognize that this question is actually a simultaneous equation. Now here's a little tip, guys. When you want to pick up that a question is simultaneous, and just walk with this in the exam, guys. Once you see a pair of equations with two unknown variables, whether it is that you are the one that created the equation or the equation was given to you, once you have an equation with two unknown variables in the same equation, most likely then it will be requiring the simultaneous technique. Again, I have two complete tutorials on simultaneous equation, both the elimination method and the substitution method. So if that's not one of your favorite topics and you'd like to kind of go through that, please be sure to check out that tutorial then. All right, so now we're looking at, say here, 3x plus y equal 2 and 4x minus 2y equals 6 intersect at x and y. Show that the points of intersection are in fact 1 and minus 1. That means you need to prove that x is 1 and y is minus 1. So we're going to go ahead then and write down our equations. Then we end up with, say here, 2x, pardon me, it says here 3x plus y equals 2, and that becomes equation 1. And we have 4x minus 2y equal, say here, 6, and that becomes equation 2. All right, now here we go. We're going to look at, then say that we're going to be equalizing the middle term. I strongly had recommended that in my video, that stick to equalizing the middle term here using the elimination method. So I'm going to just multiply this equation here by 2, and I'm going to keep this equation here at 2 by multiplying by 1. All right, so we're going to head and say 2 times 3x is in fact 6x, and 2 times y is in fact 2y, and of course 2 times 2 is in fact 4. That becomes equation 3. And then we have, of course, when we multiply any equation by 1, we will get back the same equation here. All right, and that's equal to 6. That's equation 4. Right, now since the coefficients of the terms in the middle, or since the coefficients of the y's are the same but the signs are different, the rule is that we add equation 1 to equation 2. So we're going to add here once the signs are different. So we're going to say equation 3, pardon me, plus equation 4 will give us 6x plus 4x is in fact 10x. And we know already that 2y plus the negative of 2y is in fact 0. And then of course then 4 plus 6 is in fact, say here, 10. So it works so that if we split the product between the 10 and the x, then x is equal then to 10 divided by 10. It works so that x is equal to 1, which we have already proven here that x is equal to 1. So do you see, it's not always a case where you have to get the equation. Sometimes you have to just prove that the equation is true. All right, and then now of course we're going to do the usual by subbing 4x in an equation of your choice, either equation 1 or 2. I'm just going to go with equation 1, nothing special, no special reason. So we're going to have 3 multiplied by 1 plus y equals 2. We end up then with 3 times 1 is 3 plus y equals 2. Then y then isolated becomes 2, take away 3. You see here that y is equal to minus 1. All right, and that pretty much solves our equation and prove that x is equal to 1 and y is equal to, say here, minus 1. All right, so that completes question 2 for this exam. We're about 45 minutes in. We're going to be going on to the more challenging questions then of this paper. We're going to be looking back at a topic that was taught earlier in the year. We're going to be looking at the measurement topic then. So let's dive on right in. All right, guys. So moving on to question 3, then we have the diagram below. NDS, which stands for not drawn to scale, shows a block of metal in the shape of a prism with a cross section in the shape of a trapezium. All right, and then we're given some measurements here. We're given that from S to P is 12 centimeters, S to T here is 3 centimeters, P to Q is 15 centimeters, and Q to R is 6 centimeters. And I did in fact accidentally left off a measurement here. This was in fact 10 centimeters here. All right, and so this is the basic diagram that we are in fact looking at. Now let's go on then to see what is it that they've asked us to calculate here. First thing here, they said that we should calculate the area of the cross section of the prism. And so for this particular question, what I've find is a major complaint is that students may oftentimes forget what is the cross section of the prism. So the cross section of the prism is the two identical face of the prism, right? And they have to be similar, and they all have to be congruent. So here you can see that we have a rectangular face here and we have a rectangular face here, but one rectangular face is shorter than the other, so that's not the cross section. Now, they did say in the instruction here that it's a prism with a cross section of the shape of a trapezium. So sometimes you don't know where the cross section actually is. They sometimes put it in the information here, so you now have to look for a shape that looks like a trapezium. So in this case here, the cross section then is in fact at the top and at the bottom. So it's top here, and of course we have the cross section down here at the bottom. So that's the trapezium. Now of course you're going to turn to the front of your formula, turn to the front of your booklet and look at the formula sheet. You will see that the area of a trapezium is in fact a plus b divided by 2 all multiplied by, say here, h, or you might see a is equal to half a plus b all times h, whichever one, it's the same thing. All right, now a and b represents the parallel sides of the trapezium. H obviously represents the height of the trapezium. So if you go back onto the diagram here that we're looking at then, and we take a look at our shape here, you can see that these two sides here and this side here are the parallel sides. You're running in the same directions. Already my A and my B are going to be 12 and 6, and the height of the trapezium is different from the height of the prism. In this case here, the height of the trapezium here is in fact 15, so that's 6, 12 and 15. So that's going to be that A is equal to 6 plus 12 all divided by 2, and that is going to be multiplied by, say here, 15. All right, now we then move on here to say that 6 plus 12 is 18 divided by, say here, 2, and we're going to times the result here by 15. And so of course 2 into itself one time, 2 into 18, 9, so we end up with 9 times 15 here is in fact 135 squared centimeters, and that is the area of the cross section, which is in fact a trapezium. All right, so that's the kind of interpretation that is required when you run the exam, guys. Now it went on here to say that given that ST is 3, which we have already observed from reading the diagram, we are to calculate the volume of the block of metal. So the whole entire volume is what we're looking for, and so that boils down to once again going on the front of the book, going at the front of the booklet, and looking at the front of the, looking at the formula sheet. Pardon me. At the top, you will see that V is equal to A multiplied by then here H. Now in this formula here, V stands for the volume obviously, and A stands for the area of the cross section, which we just calculated to be 135. All right, so A stands for the area of the cross section, and the 8 stands here for the height of the prism, which in this case here is ST, and ST here is 3. So therefore, when we go ahead and we multiply, then we find out that the volume then is equal to 405 cubic centimeters. All right, volume is measured in cubic units. Now it then goes on then to say here that we should determine the total surface area of the metal block. So the total surface area is pretty much the area of all the faces added together. Now of course we could then go on to say here do it individually. So we could find the area of the two trapeziums and times it by 2, find the area of this rectangle, find the area of this rectangle, and then of course find the area of the back and the area of this slant side here. We could do all of that, but it's so much easier if you have a very basic total surface area formula where we know that total surface area is equal to the surface area plus 2 times the area of the cross section. So that's 2 times A. You have to get this formula mentally tied down, guys. Okay, so once you know that, then you can go ahead then and therefore go ahead to find surface area. Now surface area is calculated by multiplying the perimeter of the cross section, and then you're going to of course multiply that by the height. So the perimeter of the cross section multiplied by the height of prism. All right, so in this case here, SA is going to be equal to the perimeter, which of course is going to go back to our diagram here, and let's have a look at the perimeter of the shape here. We have 12, we have 15, here is 6, and of course it's a uniform shape, so the 10 centimeter here is also the 10 centimeter for this line up here as well. So we have 12 plus 10 plus 15 plus 6, so 10 plus 12 plus 15 plus 6, so that's 10 plus 12 plus 6 plus 15. And then of course the height of the prism, we already know here that it is in fact 3 centimeter. So if we go on our calculator, then 10 plus 12 is 22, 22 plus 6 is 28, 28 plus another 10, that's 38, 38 plus 5 is 43, and so that's going to be 43 multiplied by 3, and that will give us a total answer here of 129 squared centimeter, and that is the surface area. But total surface area, as you can see here, is going to be surface area, which we just calculated to be 129, and that's going to be added to 2 times the area of the cross section. So already remember that the area of the cross section we already calculated up here to be 135, and there's 2 faces, so it's 2 times 135. So that's going to be 129 plus 2 times 135. That's going to be 270. And so if we add that now together, we're going to get 399 squared centimeters. And that is the total surface area, say here, of the metal block. All right. Nice, beautiful question there. So that's how you approach it. And this question is in fact coming from a 2013 past paper question. All right. So hopefully, guys, you got an understanding of really and truly how to approach the question seamlessly. Let's move on then to question 4. The diagram below shows a pair of parallel lines AB and CD with a transversal MN forming angles X, Y, and Z at the positions Q and R respectively. Angle QPR is 28 degrees, which we can see that 28 degrees here, so that's QPR, that is point Q here, P here, and R, the angle is at P, that's 28 degrees. All right, so we see that the line segment QP and PR are equal, so QP, so that's going to be from here to here, this point to this point is equal to P to R here, this distance. That's why we have these 2 strokes here. So these 2 dashes means that these 2 sides are the same. And then we of course have the angle X that is unknown here, the angle Z that is also unknown here, and the angle Y all the way down here that is also unknown. All right, now we are supposed to calculate, giving reasons for the steps to your answer, the values of X, Y, and Z. All right, and so particularly when Csec asks you questions like this, it most likely that they are connected in some way, shape, or form. So when you find angle X, then it somehow may help you to find angle Y, which therefore then will lead you to either one of them helping you to find Z, or both of them put together. All right, it is never a case. There are some situations where, depending on how advanced your geometric knowledge is, you may be able to find Y before X. But then again, we're talking about Csec here. It's not going to be as over calculated as you'd perhaps anticipate. So here we're asked to find, say here, the value of X. Now right away, because of these 2 arrows here, right, and you guys have to look out for these arrows. These arrows suggest that the lines obviously are parallel, which was told to in the information here. But what situation normally occurs when there are parallel lines involved or is being intercepted by a transversal? Well, sometimes you will find that vertically opposite angles are formed. You will most likely find that corresponding angles are formed. You will also particularly find that alternate angles, which we more commonly refer to as Z angles, are also formed. So right away I can see that since AB is parallel to CD, then I know right away that I can actually carve out a Z from this diagram. So here you can see that if I zoom up here for you and you see me with my green marker here, you'll see that I formed some sort of Z here. That is right here and right here. And so what that means for us is that if that is a Z, then we're safely saying then that the angle here in the corner, that is in fact 28 degrees, this angle here is going to be the exact same angle as the one in the corner here, which is now, as you can see here, marked by X. So therefore that also is 28 degrees. So we can start off by saying X is equal to 28 degrees, and the reason for that is that the angles are alternate. So alternate angles are equal. And if you want to be very specific, then you can safely say that, tell them that angle BQP, so angle BQP, which is the angle X, is equal then to pardon me here, let me just, it's not okay, so we have angle BQP is of course the same thing as angle X, which is therefore then equal to angle, say here, RPQ. So angle RPQ. All right, that's a lot of information to write just to get the 1 mark or the 2 mark. So just saying alternate angles are equal will be suffice. All right, moving on then now to find the angle, say here, Y. Now, remember that what I always encourage my students to do is that once you've calculated an angle, you want to put it on the main diagram. It oftentimes, if you're not as in-depth and in tune with the math, you sometimes will be always looking at the empty diagram. When you put information on the diagram here, like I'm going to just erase this from being blue and put this in red. So, okay, so it gives a little bit more pop. Right, just for you, the audience here. So this here is 28 degrees simply because this angle here so is also 28 degrees. Now that gives the pop. Now what we're looking at is angle Y, and so angle Y basically is on a straight line with the angle here that is at R. So the angle Y that we're looking for is tied with that vertex, that angle here marked by the letter R, this angle right here. So it's tied. So if I can somehow find a way to calculate this angle, then whatever the size of this angle is plus Y is going to be equated to 180, because of course angles at a point on a straight line measures 180. So I'm going to set out then, since I'm going to find an angle that is tied to the letter, the unknown angle Y here. So I'm going to find the angle right here. Okay, we can say that is angle QRP. All right, so we're going to go ahead then and say, all right, so Y degrees equal, and I'm waiting for my answer. So that's going to be QRP. So start off by saying then that angle QRP is equal then to, let's see. Now, since these two sides are the same, then it means that the triangle QRP is an isosceles triangle. That means this angle here is going to be equal to that angle there. So these two angles here are exactly the same. The one that I want and the one up here, they're equal. Now, since I have one angle inside, I can say QRP then is equal to 180 degrees, which is the total sum of the angles in a triangle minus the angle that I have. And so because the remaining angles are equal, I'm then going to just simply divide it by 2. So that's going to be 180 minus 28. So that's going to be 152 degrees. And of course, when I divide in that by 2, I'm going to get 76 degrees. So this angle here is in fact 76 degrees. So this angle here is 76 degrees. And so therefore then we can make a conclusion that therefore angle Y then is equal to 180 minus 76 degrees, and that's equal to 104 degrees. So the reason for this would have been that angles at a point on a straight line, you can say, are supplementary or sums to 180 degrees. All right, sums to 180 degrees. All right, and then of course the reason for this here, the reason why I would have actually go ahead there and calculated this 28 from 180 was simply because triangle QRP is isosceles. All right, CXC I believe will give you a distinction based on your ability to explain yourself through mathematical statements. All right, so if you may not necessarily be able to like calculate the answers, sometimes you can write and can explain yourself. What CXC looks for is that they look for understanding of the concept. It's not so much about the right or the answer being right or wrong. It's about applying the knowledge and showing them that you understand what needs to be done. All right, several things can happen in an exam where a student doesn't complete the exam, but if you can show that you understand the concept through writing a little bit of mathematical statements, that is enough to actually reward you, say here, with full marks. All right, question 5 then say here, the object JKL and J prime, K prime, L prime can be drawn by connecting the points J -4, 1, K -1, 1, and L -1, 3, whilst J single prime, all right, so okay, so the points that I had was J, K, and L, pardon me. So the points now that they've been mapped onto is J prime, 1 -4, K prime, 1 -1, and L prime, 3 -1. So you can see that there's some sort of switch up in the numbers and switch up in the signs, possibly. We'll assess that a bit closer. But let us kickstart this question here by putting the diagram on the graph. So we're looking at the first point here, which is J, K, and L, -1, 4. So let's go across here. That's -1, 4. So here's my graph. Grab my white marker here. So that's -1, 4. So that's -1 to my left and up 4. 1, 2, 3, 4. So that's this position right here. That's my J. And then therefore we're gonna go to say here. Okay, so it's not -1, 4. My bad, guys. It's -4 up 1. Okay, so -4 up 1. I'm gonna erase that. Mistakes do happen, guys, if you don't pay close attention. So that's going to be -4, 1. So that's 1, 2, 3, 4 up 1. That's right here. This is my J. And the other one I think is -1, 4, -1, 1, -1, 1, and that's K. Let's confirm that as well. -1, 1. Okay, and then the other one is -1 up 3. So that's -1 up 3. So that's -1 here. 1, 2, 3. That's JK, and that is obviously going to be L. So let's go ahead then and connect, say, this. Okay, I think that's a little bit off. So I'm gonna connect this to this to this. This is my triangle J K L. All right, so that's J K L. Beautiful. Then of course we're gonna go ahead and plot the image of this transformation here. So we have basically, if you observe carefully, it's almost like -4, 1 became 1, -4. So it basically is like a switch in the position. Notice that we have -4 was at the front, now -4 is at the back, and we had 1 at the back and now 1 is at the front. So basically all the points have been flipped if you observe carefully. So our first point here, which we had as K, was -1 up 1 here. Okay, so J, pardon me, was -4 up 1. It's going to simply be 1, -4. So that's 1, -4. So that's 1, 1, 2, 3, 4. That's J prime. K prime then we know was -1, 1. So it's now going to be 1, -1. So that's 1, -1. So it was negative 1, 1. So now it turns around, it becomes 1, negative 1. So that's J prime, and that's K prime. And then of course we have L prime, which was negative 1 up 4. It's now going to be 4, negative 1. So that's 1, 2, 3, 4, negative 1 here. And that is my L prime. Okay, let me just write my K prime on the other side here. So that's my K prime. Alright, and then of course we're going to draw this in broken lines here to show that that's the image. Alright, we're going to draw all our images in broken lines here. Okay, and this has come up here. Oops, that's a little bit off. Okay, gotcha. That is it. Alright, so you always want to kind of start off by plotting your points. Alright, and so once you're successful in doing that, then let's go on then to understand what they have said here. You're now asking us, say here, to describe fully the transformation that maps JKL onto J prime, K prime, L prime. So as was observed earlier, you can see that after taking the first point, which was negative 4, 1, all right, so we know that the first point was negative 4, 1. When you're making a comparison, when you're trying to describe a transformation but you're not sure which one is it, whether it's translation, rotation, reflection, or enlargement, you have to look for clues in how the points have alternate. So if you notice that we had the point negative 4, 1, which was my J point, so that's called up my J, and when I needed to plot J single prime, I end up having to go 1, negative 4. So you'll notice here that, of course, if I was to label this point here, say X, Y, notice here that what happens now is that negative 4 went to the bottom, or it went to the back. All right, let's just write this sideways so it's a little bit more obvious. So that's negative 4. Hold on, guys, give me a sec. So that's negative 4, 1. All right, so if you notice that the negative 4 went to the back. So it moved from the front and went to the back, and then the 1 moved from the back and go to the front. So that suggests that there was a flip in the points. That's YX. And if you have watched my reflection tutorial on my channel, a link will be pinned also in the description of this video. You'll recognize that this is in fact a reflection in the line Y equal X. All right, so this is a reflection in the line Y equal X. That means then graphically what is actually happening is that the object was pretty much reflected across this line here. This really is my line of reflection. Okay, that's my line of reflection, and we spoke about this in details in that reflection video about the line Y equal X and the line Y equal negative X. So basically this object here, JKL, was flipped across that line and it landed in this position then. All right, fantastic. So that's a reflection in the line Y equal X then, say. All right, beautiful. So then the next question then is going to be calculate the coordinates of J double prime, K double prime, L double prime, which is the image now of J prime, K prime, L prime. So J prime, K prime, L prime is now my new object. Let us see what we're going to be doing with that object. It is actually a translation by the vector -5, 3. So we must do the calculation and draw its image. So therefore then, if you remember anything about translation, you can also check a link. You can also check out for the link that is pinned in the comments or in the description of this video. You'll find the link that brings you to a very detailed explanation of the concept of translation. So that's O plus T equal, say here, I. And so of course the object then are going to be the points J prime, K prime, L prime. So we had calculated that then, and let's just go back to that. Okay, remember that they had given us the points around here. So let's see what those are. They were in fact, say here, J prime. So this is the one that we're looking for here, here, and here. So it's 1, negative 4, 1, negative 1. So it is 1, negative 4, 1, negative 1. and the last one is 3, -1. So we're going to go across to our graph here, and we're going to plot those points. All right, so let's grab a different color marker here. Let's grab, say here, blue. All right, so we're going to plot 1, -4. So that's going to be 1 to my right, -4 down, 1, 2, 3, 4. So that's going to be, say, okay, so we already have that point. So this basically is our new object. All right, so we're going to take those points, then we're going to go on our calculations here, and we're going to go ahead then and say 1, -4. All right, and then we're going to have 1, -1, and then of course we're going to have, say here, 3, -1, and we're going to add the vector, say here, -5, 3 to each of its ordinate values. So we're going to add all the top numbers to -5 and all the bottom numbers to +3. So 1 plus -5 is in fact equal to -4. 1 plus -5 again is also equal to -4. 3 plus -5 is then equal to -2. -4 plus 3 is equal to -1. -1 plus 3 is equal to 2. And -1 plus 3 is also equal to 2. So then what we're looking at then are the points J double prime, K double prime, L double prime. So let's go ahead and plot this then. Let's write this down. So that's -4, -1, -4, 2, and then we of course have -2, 2. So if you're going to go here then, and we're going to go back on our graph and try to plot it. Okay, so let's see what we get from this. So -4, -1, so that's -4, that's 1, 2, 3, 4, and down 1, this is right here, and that's my J double prime. K double prime is -4, 2, so that's -4, that's 1, 2, 3, 4, but up 2 this time. This is where we're at. That's J, K double prime. And then of course L double prime is -2, 2, so that's -2, that's 1, 2, and up 2, that's right here. That is my L double prime. So if we go ahead then and connect, say here, this with this to this, and then we're gonna connect this to this to this right here, and then we just connect these two right here, we end up, say here, with our image. All right, so we know that J prime, K prime, L prime was translated to this blue shape. I preferred if I had used a yellow or a red or something of that sort, but I guess you guys can see it. It is in fact right here. All right, so that's our translation, and that's how you do the calculation for that particular problem then. So then we're gonna move on to, now they say that JKL, which is the original figure, right? We know that the original figure was in fact -4, 1. It was -1, 1, and it was in fact, say here, -1, 3. That was the original JKL. But this time these points undergoes an enlargement of scale factor -2, which forms a triangle. We're going to call it A. So we know that the scale factor matrix is -2, 0, 0, -2. All right, we know it's K, 0, 0, K. In this case here, K is -2. So it's -2, 0, 0, -2, multiplied by the points that I've just listed, -1, -4, 1, -1, 1, and -1, 3. Let's go ahead and double those points by negative. So -2 multiplied by -4, that's +8. You just have to be careful with your signs here, guys. One wrong sign is all it takes to throw off the whole diagram. Remember that with an enlargement, the object is going to be either inversely reflected, like it's going to be backwards but bigger, or it's going to be bigger but at the same time in front of the object. All right, so that's going to be -2 times -4, that's +8, and -2 times 1 is -2. So then we have -2 times -1 is +2, and then we have -2 at the bottom times 1 is -2. And so we have -2 at the top again times -1 over here, that's +2, and negative 2 multiplied by 3 is in fact, say here, let me make certain. So we have negative 2. Okay, so this is negative 2 times 3. That's going to be negative 6. All right, and this is going to be my triangle A. So I'm going to go ahead then and plot that. Let me just write these down right here. So that's 8, negative 2. We have 2, negative 2, and I have 2, negative 6. All right, so then go on our graph, and we're going to plot these points here to see what the enlargement looks like. Let me grab purple, pink. Let's do pink this time here, just so we can see clearly. So 8, negative 2, so that's 1, 2, 3, 4, 5, 6, 7, 8, down 2, so that's right here. And then we're going to have 2, negative 2, so that's 1, 2, 1, 2 right here. All right, and then we have 2, negative 6, so that's 1, 2. Okay, so that's going to be 1, 2, 1, 2, 3, 4, 5, 6 right here. All right, then we're going to connect, say here, this to this to this to this to this, and then of course coming down like that. And you can see that the original triangle which we had drawn there is in fact getting larger. It has gotten a bit larger. All right, beautiful. And it's a reflection, negative reflection, all right, negative magnification. And that pretty much answers the question. No, I've not really seen where Csec has ever done something like that where they give you more than one transformation, probably one, at most two, or they'll give you a bunch of transformations and ask you to determine which one it is. But you can be open-minded to anything, all right? That question particularly was, I designed that question myself, okay? And that's it, guys. That's it for that question. Now, question 6 here, at the time of making this video and at the time of teaching this topic, the students that I were teaching, some had completed trig and some had completed matrices. So I had to give them an option between trig and matrices. They all did the trig and the matrices, so that's really good for them. All right, now we're looking here at the diagram below. Shows two right triangles, QSR and QST, drawn within a scalene triangle, QTR. So let's have a look at that. QSR, that is Q here, that's Q here, S right here, and R, confirm that that's a right angle triangle. That's what they said. And then we have, of course, QST, so that's Q again, S here, and T out here. Of course, confirm that that is a right angle triangle. And it is drawn within a scalene triangle, which is the big one on the outside, QTR. That's the big one on the outside. Beautiful. The line QS is drawn perpendicular. So let's identify this word here. QS is drawn perpendicular. That also emphasizes that the point of intersection of RT by QS is in fact 90 degrees. So that confirms it. The angle QRS, that is QRS, the angle that is at R, measures 34 degrees, which we can see clearly on the diagram. We have to use the dimensions on the diagram to therefore then go on to find the length of the side RS and the RT from the diagram below. So we know that one side is 11 and one side here is 9. Now when it comes to the triangles, but specifically the right angle triangles, you have two formulas that usually plays a role hand in hand in getting to the answer, especially when it comes to finding the length. It's either going to be the Pythagoras theorem or it's going to be one of the trig ratios, which is abbreviated by the mnemonic SOHCAHTOA. Of course, you can check out links on my playlist. You can check out my trigonometrical playlist that is pinned in the description of this video as well. So then if we look at the triangle that contains, say here, RS, this is over here. We are in fact looking for this side here. We know that we can use the 34 and the 11 to our aid. Now, we know that to use Pythagoras theorem, you would have to have been given two sides of that triangle, but we only have one, so that eliminates the whole thought of using Pythagoras theorem. We're then going to have to use a ratio. Now, as I've explained to you in that video, the very first thing that you do when you want to know which ratio to apply is to in fact label your sides. So already I know that the 90 degrees already tells me that the 11 is my hypotenuse. And I know that I am, of course, in search of RS, which makes this RS here my adjacent side. Why is that my adjacent side? Because the 34 degree here is steering at this side right here, which makes this my opposite side. So I know that I am in search of RS, which is the adjacent side. And of course, I was provided with the length of the hypotenuse. So according to SOH, CAH, and TOA, you'll notice that we need the ratio that involves A and H. And in this case here, it is CA. So therefore, we know that cosine theta is equal to the adjacent side divided by the hypotenuse. Many students struggle with this aspect of math. They keep making the wrong choice, or they just get so confused they don't know which ratio to be applied to which question. So there you have it. That's how you choose your ratio. All right, so then we're gonna move on to say here, I'm putting in the numbers. So we know that the angle is represented by cosine theta. So cos of 34 degrees is equal to the adjacent side, which in this case is RS, which is what we're looking for, or divided, say here, by the hypotenuse, which in this case here is 11. So if we hop onto our calculators here and we try to find, say here, the cost of, say here, 34 degrees, you'll find that the answer is 0.829. So that's going to be, let's go over here, 0.829, and that's going to be equal to, say here, RS divided by 11. So we're going to multiply, cross multiply here. We're going to say 11 multiplied by, because the unknown is at the top, so we're going to multiply by 11, and you're going to find here that 11 multiplied by 0.829, oops, 0.829 is going to be equal to RS. RS then works out to easily be 9.1. 9.1. All right, beautiful. So that is how you apply the ratio. So again, as I always advise, once you find an answer, take it and place it on the diagram. So I like to write my 9.1 here. I don't know if it's going to be needed later on as a visual. Now we're going to move on then to finding the side that is in the, looking at the triangle with the side RT. Now it looks like the whole entire outside triangle is, its base is RT. So we have a little problem here because, of course, so far we only know of the Pythagoras theorem and we know of the trig ratios. So far we don't know much about triangles outside, right? Because of course this video is tailored for the students that participated in this exam. So at the point of making this video, the students may not have known about the cosine rule or the sine rule or anything like that. So here we're gonna have to improvise then by looking at the fact that RT, then we can go ahead and say RT then is in fact made up of two smaller sides, which is RS and ST. So if you notice that it is this piece here and this piece here really makes up RT. So therefore then I know that if I want RT, I would have to find RS and ST. Now I already found RS, which is 9.1. Now I just need to find ST. And if you look at ST here, you'll realize that we're also on the other side of the right angle triangle. Now this is 20 degrees here. So there's a little bit of changes with my opposite and my adjacent. Now because the 20 degrees is here, this now becomes my opposite side. Before the 34 was down here, so that is my opposite side. Now my opposite side is now ST because it is in front of the 20 degree on this right angle triangle. And so therefore then the side that I'm looking for here is going to be the opposite, and the side that I was given was in fact the hypotenuse. So now it's forced me to have to use the ratio with O and H, which in this case is so. So we can proceed then to say here sine or so implies that sine of the angle is equal to opposite over hyp. So we're going to go ahead and find the sine of 20 degrees, and that's going to be equal to the opposite side is, in this case here, ST, and the hypotenuse side here is 9. So you can go ahead and sine 20 degrees. Ensure that your calculator is in degree mode. It is 0.34. And that's going to be equal to ST divided by, say here, 9. Now, of course, as usual, if the unknown is at the top, we're going to multiply. So ST then is equal to 9 multiplied by 0.342. Add an extra decimal place here, guys. So therefore then, if I multiply this by 9, I'm going to end up here with 3.07. So ST then is equal to 3.07. Alright, in this case, centimeter. So therefore then, just grab my black ink here, and I'm going to therefore then go back to the formula here that RT then is equal to, we know that RS is 9.1, and ST then we've just calculated to be 3. We can say 3.1 as well, round off. So RT is approximately equal to 12.2 centimeters. Alright, and that is how you solve this trig question. All right, so there was not much on trig that I gave the students just to test their ability and memorization on the concept of trig ratios. Of course, if you guys want to advance your skills, a link will be pinned to my, well, a link will be pinned in the description also of this video that takes you to my trigonometrical ratio playlist. So check that out at the time more convenient to you. And so, of course, last question here, given that the matrices below are in fact, as you see it here, t equals -1045 and x is 3, -10, -4. We have to calculate the following below. So we have to calculate matrix t, take away 2 times matrix x. So matrix t is in fact -1, 0, 4, 5, and we're going to therefore then take away the scalar 2 times the matrix x, which in this case is 3, -1, 0, -4. So just writing back down this matrix here, -1, 0, 4, 5, and we're gonna subtract then, say here 2 times 3 is 6, 2 times -1 is -2, 2 times 0 is 0, 2 times -4 is -8. Alright, remember that a scalar matrix is not matrix multiplication. You're just using a scalar to magnify the matrix. So now easily then we know the routine of adding matrices. If the entries are the same, then first, second to second, third to third, fourth to fourth. So we end up with -1, take away 6 is in fact -7. 0, take away -2, the 2 negatives becomes a positive, so 0 plus 2 is 2. 4, take away 0 is in fact 4, and 5, take away -8, the 2 negatives becomes a positive, 5 plus 8 is 13, and that's the result of the difference of 2 matrices along with a scalar. The next question here, let me just erase this so you can see clearly. It is x to the t plus 3t. Now, when you see that a matrix is raised to a capital T, it means that you're going to transpose the matrix. And so to transpose the matrix then, what we do is that we take the matrix row and turn it into a column. So since it's xt, I'm going to take the row of matrix x here and turn it into a column. So that's 3, -1 written downwards. And then we're going to take, say here, the next row here, 0, -4, and turn it also into a column. So that's going to be my x to the t. Then I'm going to just add 3 times the matrix t here. Alright, so that's 3 times the matrix t, which in this case is -1, 0, 4, say here, 5. So therefore then we're going to go ahead then and rewrite the first matrix 3, 0, -1, 4. And we're going to therefore add, say here, 3 times -1 is -3. 3 times 0 is 0, 3 times 4 is 12, and 3 times 5 is 15. And then of course first with first, so that's 3 plus -3, that's going to be equal to 0. 0 plus 0 is 0. -1 plus 12 is 11. And 4 plus 15 is 19. And so that therefore then represents the result of that matrix transposition and its scalar, and a scalar. All right, so pretty good there. All right, this is the level that my students are at the moment of watching this video. Let me know in the comments, guys, if you've seen some of these things for the first time, or you've seen it before but you just never get the concept. So let me know in the comments. All right, I'd love to hear from you guys. T to the T means, once again, I'm going to take the matrix T this time. This is the one over here, and I'm going to transpose that matrix then. So I'm going to therefore take, say here, this row here, negative 1, 0, and turn it into a column. So that's negative 1, 0. And we're going to take this next row here, 4, 5, and we're going to turn it also in a column, 4, 5. Then we're going to subtract 3 times the matrix X. So that's 3 times this matrix up here, 3, negative 1, 3, negative 1. And we're going to have 0, negative 4, 0, negative 4. All right. So we go ahead then and we just say here negative 1, 4, 0, 5, and minus 3. Okay, we're going to just distribute this here. So that's going to be minus, open the bracket, 3 times 3 is 9, 3 times negative 1 is negative 3, 3 times 0 is 0, 3 times negative 4 is negative 12. And then of course the usual, or if the entries are the same, first with first, that's negative 1 minus 9, that's equal to negative 10. 4, take away negative 3, so that's 4, take away negative 3, that's 4 plus 3, which is 7. 0 minus 0 is 0, and 5, take away negative 12, is in fact 5 plus 12, which is 17. Alright, beautiful. And that brings us to the end of the whole entire exam paper. So for you guys who actually got back your results, once again, you've been given the opportunity here to look at, say here, the solutions to this exam that was most recently concluded. All right. Now, my adult students are going to get a similar exam, so that video is also going to come out as soon as next week. So also look out for yet again another opportunity for another review exam paper. These review exam papers are good fundamental practice as you build up throughout the whole year, as you go through the whole year, and you see how you gauge yourself through consistent assessment. You'll then appreciate the value of these videos here. All right, so hopefully you guys, if you are watching this channel for the first time, you are in fact already subscribed. And if you're not, then go ahead and do so for me. Leave a like, leave some positive questions and comments down below. Do not forget to share this out to your math communities. Alright, if you're doing CSEC, CCSLC, SEA exams, EDXL, IG, CSE, or any one of those Caribbean exams or overseas exams, you can find all my information pinned in the description of this video. Alright, of course, feel free to contribute towards the channel's growth by donating to my PayPal account or just in general my local accounts. Alright, I do appreciate the support, the continued support in the growth of this channel as we seek to improve the mindset and improve the mathematical ability of our Caribbean students. Alright, so until then, take care. I'll see you in the next tutorial. Bye bye.